So today when we solve, we're going to be solving things that are bigger than binomials or trinomials. They have, like you can see, number one has 4 terms. 1, 2, 3, 4 terms, right? In the past, we've used grouping, right? We use group. So when it's grouping, when it's the last set of notes we did on Wednesday, you guys did with Mr. Lara, they look like this, right? You used grouping. You put the first 2 in a group, the second 2 in a group, and you went from there. The problem with that today is it's not going to work. Grouping is not going to work with these guys. If you try to use grouping, it's not going to work. I'll show you. I'll give you an example. You don't have to write this part down. I'll just show you how it's not going to work. Let's see, plus 6x squared minus 5x minus 2. So there's no overall GCF. Like, let's say I was trying to do this like I did on Wednesday, and you guys did yesterday with that group activity. And then you're like, okay, so no GCF, so put the first 2 in a group, right? 9x cubed plus 6x squared negative 5x minus 2, right? And then you're like, okay, GCF here is 3x squared. So you get 3x plus 2. This is where grouping fails today. Is there any way for me to make this into this using division? Like, is there any way I can divide both of these guys to make a 3x and a positive 2? I can make a positive 2, right? Negative 1. You could do that, right? Negative 1, but then you'd also have to do it there. Would that become a positive 3x? No. So there are some times when grouping doesn't work. So when it doesn't work, we have division. We're going to use something we've done before. Okay? So let's look at number 1. Okay? So this is what happens if we can't use grouping. Try grouping. If it doesn't work, division. Division always works. Division will always work. Okay? All right, so first thing we got to do is make a list of possible answers. How many answers is this guy going to have? 3. Yeah, 3, because that's the biggest power, right? We talked about that. So now first thing I got to do is find a list of possible answers. Okay, possible. So how do I do that? Well, it's on the board, and I'll write it right here. I'm going to make a little line there. So this is possible answers. Possible. Possible roots. What does the word possible mean? Like, what does that mean when I say these are possible answers? Could be, right? Could be. Not necessarily are. It's like if I'm applying for a job. I'm a candidate. I don't get the job until they say you're hired, right? So what we need to do right now is make a list of all the people, all the numbers, anything that could be. Okay, so how are we going to do that? First thing we're going to do, get the factors of the constant. Okay, so a couple big words there. Let's start with constant. What is a constant? Or what is the constant?
9, 6.
So those are coefficients. Yeah, the 9, the 6, and the negative 5 are coefficients because they're in front of x. Negative 2 doesn't have that, so we call that a constant. All right. What are the factors? So what does factors mean? Right? What are factors? Multiples. Yeah, numbers that multiply to be that guy in orange. So what are the numbers that multiply? So let's make a little list here. It's going to be literally a little list. It's not going to be a long list. 1 second, let me answer the phone. What are the numbers that when we multiply make negative 2? Negative 2, positive 1. There's one other group. What other 2 numbers multiply to be negative 2? There you go, right? Positive 2, negative 1, right? That's it. So those are the numbers we're going to list on top. There's 4 of them, right? I'm going to write this a little different because I have a positive 1 and a negative 1, right? So I'm going to put a plus and minus 1, plus and minus 2, just so that I don't have to write super long. Okay, those are the factors of the constant. Bottom is the factors of the leading coefficient. Factors of the leading coefficient. Okay, so we know what factors means. What's the leading coefficient? 9, yeah. Leading means guy in front. Coefficient means number in front. 9. If it's in standard form, the leading coefficient is going to be positive 9. So what are all the numbers that multiply to be positive 9? 3 times 3, 9 times 1, right? Is there anything else I'm leaving out? Negatives. There you go, right? Negative 3 and negative 3. And negative 9 and negative 1. So I have positive 1 and negative 1. I'm going to put that on the bottom. Positive 3, negative 3. And positive 9, negative 9. Okay. So far just pencil. Well, I'll tell you when we need to change the pen or marker. But just pencil right now. Okay, so now we need to make a list. So how are we going to make a list? Well, what does that line in the middle mean? When you see that line, what does that usually mean to do? Division, right? So we're going to divide. I'm going to divide every number on top with every number on the bottom. Okay? It's in the back. So let's start with 1. What's 1 divided by 1? 1. What's negative 1 divided by 1? Negative 1, right? So 2 possible candidates are positive 1 and negative 1. When you divide, I could get positive 1, I could get negative 1. Okay? Now let's do 1 divided by 3. What is 1 divided by 3? 1/3, right? If 1 is on top, 3 is on bottom, that's 1/3. It's a fraction. So plus and minus 1/3. Now 1 divided by 9. If 1's on top, 9's on bottom, it's not 9th, it's 1/9, yeah. Plus and minus 1/9. Good. So done with the 1 on top. Now I got to divide the 2 on top. 2 divided by 1. Positive 2. 2 divided by 3. 2/3. 2 divided by 9. 2/9. That's a list of possible candidates. Now, are these the answer? No, they can't be. How many possible candidates are there? Careful. How many possible candidates are there? Not 6. It's like there's 6 numbers though. 1, 2, 3, 4, 5, 6. 12. Yeah, because there's 2 in each, right? So there's 12 possible candidates for this job. Can't pick all 12. I only need 3 people. So we got to figure out which 3. Okay? So that's step 1. That's the only step you haven't done. Every other step today that we do, you guys have done before. That's the only new step. Step 2, we're going to use division. I'm going to use synthetic division because it goes a little faster. Could you use long division? Yes, you could use long division. I just choose to use synthetic division since it goes a little faster. Okay? So we're going to set up synthetic division for this guy. So this is where your pen comes in. Pen or marker. Okay, so when we set up synthetic, we put a little house, right? You're going to do this in pen or marker. We have a little house, right? And then we put numbers. Which numbers are we going to line up here? Do you remember from last chapter?
The one you're dividing.
So which numbers are there?
1 and 2.
Those are the numbers that are going to go in the house. What numbers go here? There you go, right? 9, 6, -5, -2. Okay, so in pen, let's do that. 9, 6, negative 5, negative 2. And then we put a plus and then a line underneath, right? So when I do synthetic division, how am I going to know if that guy gets the job? How am I going to know if that's an answer, that's a root, that's a 0? I'm going to get 0 remainder, right? 0 remainder. So let's put that in pen too. 0 remainder. Okay, so now put the pencil back. Once you wrote that, put the pencil back in your hand. Okay. So these are our possible candidates. This is, in other words, the interview process. This is the interview process. You work if you get 0 as a remainder. So where do I start? I start in the front. Let's start with positive 1, see if it works. Let's see if positive 1 works. So in pencil, positive 1. So what was the first step for synthetic division after I put the guy in the house?
Put the 1 right there in the bottom.
Yep. First guy takes the elevator straight down. And then what did I do? Multiply. Yeah, multiply. 9 times 1 makes 9. Add straight down, I get 15. 1 times 15 is 15. Negative 5 plus 15, 10. Multiply one more time, positive 10. Is that going to give me a 0 as a remainder? No. So positive 1 doesn't work. So this is what we're going to do. We're going to erase the pencil stuff. So the pencil stuff should be this stuff here. Okay? Because when you go through interviews, some of you guys have jobs, you know this. When you go through interviews, they ask the same people the same questions. So the person who comes after me, they're going to ask them the same questions they asked me. So we're going to leave this up there. Okay? So now we tried positive 1, didn't work. So let's try negative 1 now. Let's try negative 1. Do the same process again. Move 9 straight down. 9 times negative 1 is negative 9. 6 plus negative 9 is negative 3. Negative 3 times negative 1 is positive 3. Oops, not negative 5, negative 2. Multiply. Does that give me 0?
Yeah.
Found my first guy. My first answer is going to be negative 1. First answer is going to be negative 1. How many more answers do I have left? 2. So I got to figure out the first 2, the next 2. How am I going to do that? Well, you have options. You could either factor or use division again. I'm not going to use division right now. I'm going to use factoring because how many terms are going to be left? 1, 2, 3 terms. That's a trinomial, right? So let me give back the x's and x squareds like we did last chapter. Oops. Okay. When we divide, we go down in power, right? So we started with 3 at the very beginning, so that means the leading is not going to be to the 3rd power. It's going to be squared now, right? And then this guy is just going to have 1 power, and this guy is going to be the coefficient. Or sorry, the constant. All right? That guy's a trinomial. I have steps. We did that. That's what we did on Monday. We found solutions. We found zeros for trinomials. We use these steps right there. All right? So that's what we're going to do again. First step, is it in descending? Is it in standard form? Yeah, it goes in order. Second step, is there a GCF? No, close, right? If this guy was a -3, it would work, but no, there's besides 1. So let's go to the next step. A, B, C. A, B, C.
So once you find your first person, then you can do it?
Yes, if it's a trinomial. On the other side, when we go to the back, it won't be that way. Those are a little different. But yeah, so if you get a trinomial after the first time, then you can go there. That's our goal. We want to get to this so that I can just use those steps. So I don't have to use division every single time. Division is nice to use, but it's kind of hard when you don't know what this guy is. You have to kind of guesstimate what that guy's going to be. Okay? So A is 9, B is -3, C is -2. A times C, -18 on top, -3 on the bottom. So I'm looking for the two numbers that multiply to be -18 and add to be -3. Six and 3, one of them's got to be negative, right? -6, right? Because when we add them, they got to be -3. Good. First term goes in the first box, the first little section. The last term goes in the last little section, just like always. I'm not changing. This is the same from that you guys have been doing all year long. One is a -6x, one is a +3x. So I know it's going to be x times x. So there's two ways to make 9 using multiplication. 9 times 1 and 3 times 3. Which one's going to work for this guy? For example, if I put a 9 here.
No, 3.
Yeah, right. If I put a 9 here, it's not going to work because it doesn't fit into 3. And if I put it over here on the left, it's not going to fit into -6.
Our C is 2, but why'd you put 3 as C? Wait, never mind, that's B.
Yeah, is B, yeah. No worries. So it's going to be 3 and 3, right? So -2, +1. So now we're going to set those two guys equal to 0, just like we've been doing all chapter. And that'll give us our two last answers. We're going to add 2 to both sides. Divide by 3. So one of my answers is +2/3. The other one, I'm going to subtract 1 from both sides. Divide by 3, divide by 3. -1/3. So those are my last two answers. So now, altogether, I have 3 answers, which I said from the beginning I was going to have. Were those 2 answers on my candidate list? +2/3, -1/3? Yeah, they were. But I probably wouldn't have got to them if I just used division. That's why the trinomial part was important. You can use fractions in synthetic division. You could. I wouldn't really suggest it, because it kind of gets ugly, because you have to multiply fractions and add fractions, but you could. Chances are I wasn't going to put a 2/3 in here, or a -1/3 in here. Right? So that's why we use steps we've already used. Okay? All right, so let's go to the back now. That's essentially what we're doing. Finding the zeros, finding all the zeros. Well, before we find zeros, sometimes they'll be nice, and they'll say, hey, this guy's a 0. They'll give you a little starting point.
Would you say this is like the longest one? Like it's longer than...
Yeah, because we're going to need to find 4 zeros, right? So this one is going to be a little bit longer than the last one. Yeah. This one's going to be a little bit longer than the last one. Okay? List of candidates. On top is the list of the factors of -6, because that's the constant. On bottom is a list of the factors of 2, because that's the leading coefficient. All right? So what are all the numbers that make -6 to multiply to make -6? There's not a lot. How do I make -6 using multiplication? 3 and 2. One of them's got to be negative, right? So let's see. Let me write this down. -6. We get -3, +2, and then reverse. -6 and 1, -1 and 6, right? So what do we got? Plus and minus 1. Plus and minus 2, positive and -2, positive and -3, positive and -6. Now we got to make the factors of 2. There's not a lot of them. What are the two numbers that multiply would be 2? -2, -1, right? +2, +1. So that's positive and -1, positive and -2. Divide everything. Divide all the tops by all the bottoms. So start with 1 divided by 1. Positive or -1? Divide these two guys now. Positive and -2. Divide these two guys now. Positive and -3. And the last one, positive and -6. I multiplied all of the orange with positive and -1. Now I got to divide all of the orange with positive and -2.
Can you do it backwards?
Yeah, the order doesn't matter. As long as you have all of the candidates out there, order doesn't matter, yeah. So now I got to divide these guys by this guy. That's 1/2. Positive and -1/2. Next guy. What happens when I divide these two guys? It's just 1. I already got that on my list, so I don't have to write it again. Positive and -3/2, or 3/2. And then the last one is 6 divided by 2. That's just 3. 3 is already on my list, so I don't need to write it again. So how many candidates do I have? Not 6, 12. Yeah, each one has 2, right? Each one has 2. So I have 12 again. Okay. All right, let's get our pen out then. Let's get our marker or our pen. Let's start interview process. Okay, so what are the lists? What's the list I'm going to put in first? What's the first number I'm going to, not in the house, to the right of the house? 2, 9, 6, -11, and -6. Good. So all of this I'm going to do in pen because I don't want to have to erase. Okay. Sometimes they're going to be nice, and they'll say, hey, I'll give you an answer to begin with. You just have to find the others. So I'll do that this time. So one of the answers for this guy is +1. One of the answers is +1. That's an answer. Find the other 3. Well, if they've given me one answer, shouldn't it work? Put it there. It should work. Test it out. Does it work? It works. They were right. They weren't messing with me. I can't use it again because I could only use it once. But sometimes they'll do that. They'll say, here's an answer. It's not a trinomial yet, though. Yeah, that's the problem. It's not a trinomial yet. So I can't go to my steps. So what do? Do division again. Do division again. So in pen, except it's not going to be the original. It's going to be what I have left. So it's going to be 2, 11, 17, 6. The goal is still the same. I want a remainder of 0. Okay. Use a little deep thinking. Think a little deeper than just on the surface. What types of numbers?
Whole numbers.
They're all whole, and what other type? Starts with a P. Positives. They're all positives, right? What do I want to eventually get?
Zero.
So if I have all positives, and I want to eventually get 0, do I want to put a positive number here? Because won't that make the bigger when I multiply and add? Doesn't that make things bigger? I want to get down to 0. So instead of positive numbers, let's just focus on negative numbers, because then I'll get negative numbers in the mix here, which is good. So negatives. So let's try -1. I haven't tried -1. I tried +1. Let's try -1. Multiply, you get -2, 9, -9, 8, -8. Close, but not quite there. So -1 doesn't work. So let's erase -1 and erase everything, not everything, but just the stuff that was in pen. Okay, so 1 we know works. I already got that answer. -1 doesn't work. The next number on the list is 2. Should I use -2 or +2? -2. For the same reason we just talked about earlier. I want these guys to cancel out. To cancel out, I need negatives. So let's see. 7, multiply. Yep, this one's going to work. 3, -6, it works. I got my next answer. Now it's a trinomial. We can finish how we did the last time. Give this guy, give this guy, give this guy all of their x's. So I divided twice. So it's not going to be x to the third, it's going to be x squared. Give me the other 2 answers. From here, you guys should be able to do it because we've done it before. What's A, what's B, what's C? Well, actually, there's no GCF. We should always ask that question. There is no GCF, 2, 7, and 3. A is 2, B is 7, C is 3. What are the 2 numbers that multiply to be 6 and add to be 7? Right? Because I got to multiply to be positive and add to be positive, so it's going to be positive. First guy always goes in the first spot. Last guy always goes in the last spot. And then it's going to be positive 6x, positive 1x. To make 2, one of them's got to be a 2, one of them's got to be a 1. I'm going to put the 2 to the left because that's going to go in positive 3 times and positive 1 time. Last step, get your 2 answers. X plus 3 equals 0. 2x plus 1 equals 0. Subtract 3 from both sides. There's one of them. Subtract 1 from both sides. Divide by 2. Negative 1/2. There's my last 2. Okay? All right. All right, one more problem, then we're done. So this one I want you to do on your own. I'm going to give you some help here. So let's look at it. It looks different, right? They got different words and they got different, but it's the same thing. It says this function has at least 2 roots. No, we know it's got 4 roots. At least means it could have more. Use the rational root theorem. What is the rational root theorem? It's this here. These 3 steps are the rational root theorem. I didn't put the words in there because it's not really important what the name of it is. What is important is you know how to use it. So this is the rational root theorem right here. Okay? To find those guys, I'm going to give you one answer. Positive 2. Positive 2 is a root. Find the others. Positive 2 is a root. Find the others. That's a semicolon, it's not a J. It's a semicolon. So what do I do first? Yeah, so give me the list of possibles. It's going to have a big list of possibles. I don't need every single possible. It's going to have something like 20-something possibles. I don't need every single one of those possibles, right? Just because I have 20 people apply for one job doesn't mean I got to go through all 20. I just have to go through everyone until I find a person that I like, right? Do I already know someone I like? 2. So let's start with 2. I like 2. So what am I going to put next? What goes with here? 9, there you go. 9, negative 12, negative 32, positive 48, negative 16.
I realized a horrible mistake and fixed it.
Oh, perfect.
Hopefully.
You're good now?
Hopefully.
Okay.
Also, on my work, it's kind of confusing. Basically, in case I get it wrong.
Does 2 work? It does work. Because you get 9, 6, negative 20, 8, and it works. Can I go to trinomial steps? No, not yet. So I got to do it again. 9, 6, negative 20, 8, little house, plus 0. I have nowhere else to go now, so that's where I need my list. So the list, unless they specifically ask for the possible, do they ask for the possible answers? No, they just say, give me the real answers. I want the actual answers. So the list, if they're just looking for the answers, it's just you don't need to do it. But right now we need to because I have nowhere else to go, right? I have no other clues. So what's a number that would be on the list that we should try? Well, what would the numbers be on top? 16, 4, 8, 2, and 16, right? And on bottom, what were the numbers that should be there? 3, 1, and 9, right? So we've already used 2. What's another one we should, because there's a lot, because you're going to get 1/3, 1, 1/9, 4/3, 4, 4/9, 8/3, 8, 8/9, 2/3, 2, 2/9, 16/3, 16, 16/9. That's a lot of guys that we're going to have. We just need one more that works. So where should we try?
The one that's gonna be a whole number?
Let's try a whole number. Yeah, let's try one of the whole numbers. So one of the whole numbers would be 1, 4, 8, 2, 16. So when I say those numbers, I mean positive and negative. Positive and negative 1. Positive and negative 4. Positive and negative 8. Positive and negative 2. Positive and negative 16. Try those. Don't worry about the fractions. Let's try those. We've already tried 2. What number should we try? 1. Let's try 1. No, it's close, but it doesn't work, right? 4? Let's try 4. Nine, 36, 42. Whoa, that's going to be big. 168. Yeah, see, that's when you guys start doing this enough, you can see it's not going to work, right? So then take it off the list. Is there a number that we got 1 and 4? 3, is 3 on our list? 3 is not on our list because it would have to be, if 3 was on top, it'd be okay. I'll give you a hint.
8?
Negative 2, yeah, negative 2.
Oh, because the thing changed too.
Yeah, there's little things you can look for that help you figure it out. There we go. Negative 2 is another answer. Now, how many terms do I have left? 3. Use your trinomial steps now. Find the other 2. So that would be 9x squared, negative 12x, positive 4. GCF? Nope. ABC. So we get 9, negative 12, and 4. 36 and negative 12. Negative 6 and negative 6. So we got 9 again, right? We can do 3 times 3 or 9 times 1. 9 times 1 is tough because 9's a big number. So I think it's just going to be 3 and 3 again. So we're going to get the same answer twice.
You could get the same answer twice.
Yeah, so it's called the double root. It's okay. Okay, there's our 4 answers. Done.